Hello, my name is Kurnia Matrix BS2311009K. I will explain the biodiesel production process. So basically, biodiesel is produced through a reaction called esterification. In the reactor, the oil reacts with methanol with the help of a catalyst like NaOH or KOH, and it produces biodiesel and glycerol. After that, the mixture goes to the separator, where it forms two layers. The biodiesel will be on top, and glycerol will be at the bottom. Then the biodiesel is purified by washing to remove impurities and drying to remove water. For question 1b, there are a few factors that affect the biodiesel yield. First is the temperature, which is around 60 degrees, and it helps the reaction happen faster. Then a higher methanol to oil ratio can increase the yield. The catalyst helps to speed up the reaction, and enough reaction time is needed to make sure everything reacts completely. Also, good mixing is important so the reactants can mix properly. For question 1c, there are some ethical issues especially when using palm oil. For example, it can cause deforestation and loss of biodiversity. There is also the food versus fuel issue and carbon emission from land clearing. So it is important for industry to use sustainable practice and reduce the impact on the environment. For question 2a, I will explain the function of each unit in biodiesel production. First, in the reactor, the oil reacts with methanol and a catalyst to produce biodiesel and glycerol. Then the mixture goes to the separator, where biodiesel and glycerol are separated into two layers, with biodiesel on top and glycerol at the bottom. After that, the biodiesel is washed to remove impurities such as catalyst, methanol, and salt. Finally, it is dried to remove water and improve the quality of biodiesel. For question 2b, there are several ways to reduce waste in biodiesel production. For example, excess methanol can be recycled to reduce chemical waste. Using better catalysts can help minimize salt formation. Also, improving reaction condition can reduce byproducts, and glycerol can be reused instead of being disposed. Question 2c. Glycerol is an important byproduct that must be handled properly. It can be reused in industries such as cosmetic and pharmaceuticals. However, if it is not managed properly, it can cause environmental pollution. So industries have the responsibility to ensure safe handling, proper treatment before disposal, and to follow environmental safety regulations. For question 3a, I will explain the reaction mechanism of biodiesel. Biodiesel is formed through a step-based reaction called esterification. In this process, three glycerides react with methanol in the presence of a catalyst like NaOH or KOH. The reaction happens in steps, where three glyceride is converted into diglyceride, then monoglyceride, and finally glycerol. At each step, biodiesel, which is methyl ester, is produced. For question 3b, this slide shows the structure of three glyceride and methyl ester. Three glyceride consists of a glycerol backbone attached to three fatty acid chains. After the reaction, these fatty acid chains are converted into methyl esters, which form biodiesel. The methyl ester structure is simpler and has lower viscosity, which makes it suitable to be used as fuel. Question 3c. There are some safety issues in biodiesel production. Methanol is toxic and flammable, while NaOH and KOH are corrosive chemicals. Exposure to these can cause burns and health problems. So it is important for industries to follow safety measures such as using protective equipment, ensuring proper ventilation, and training workers to handle chemicals safely.
Hi, my name is Nur Akida and my number metric is BS2311028. Okay, so first is hydrogenation. So basically, this is process used to convert liquid oils into semi-solid or solid fats. Hydrogen gas is added into the oil using a nickel catalyst under high temperature and pressure. As you can see, this reduces the double-double bonds in fatty acids, making the oil more stable and increasing its shell life. Now let's look at the structural changes. So basically, the carbon-carbon double bonds are converted into single bonds. As you can see, this increases the saturation level and allows the molecules to pack more closely. That's why the melting point increases and oil becomes more solid. However, partial hydrogenation can produce trans fats. So we moving on the health and ethical issue. So basically, trans fat can increase bad cholesterol and decrease good cholesterol, which may lead to heart disease. As you can see, this is a serious health concern. From ethical point of view, industries should avoid using harmful substances and must provide clear labeling. Alright, now for the refining process. So basically, crude oil goes through several steps to remove impurities. It starts with deguming, followed by neutralization, washing, bleaching, and finally deodorization. As you can see, each stage improves the quality and safety of the oil. For the next is, as you can see in this slide, the process starts with from the crude oil goes through multiple stages until refined oil is produced. Each step plays an important role in removing impurities and improving the final product. Now for the food safety responsibility. So basically, the industry must ensure the oil is safe for the consumption. As you can see, this includes removing contaminants, maintaining hygiene, and following safety standards. Proper labeling is also important to protect consumers. For this slide, we have saponification. So basically, this is the process of producing soap from fats using sodium hydroxide. As you can see, the reaction breakdowns triglyceride into glycerol and soap. So for the soap structure, so basically soap has a hydrophobic tail and hydrophilic head. As you can see, this allows it to interact with both oil and water, forming micelle that trap dirt and help in cleaning. Lastly, for environmental ethics. So basically, alkaline waste from soap production can harm aquatic life if not treated properly. As you can see, industries must treat this waste and follow environmental regulation.
Moving on to the question 1, I will be discussing the craft process, which is essentially a giant recycling loop for turning wood into paper. As you can see in the diagram from smoke, the process starts in the digester. We cook wood chips with a chemical mixture called white liquor to break down the lignin and release the cellulose fibers. Once the pulp is washed and bleached for whiteness, it is sent to the paper machine to be dried into final sheets. However, the real magic happens in the recovery loop. Instead of disposing of the used chemical or black liquor, the mill processes them through an evaporation plant and a recovery boiler. This allows us to regenerate our own white liquor right on site. This closed-loop system is our primary industrial responsibility. By recycling 99% of our chemicals and using safer bleaching methods like ESCF, we can solve the historical problem of water pollution and sulfur odors while keeping the mill sustainable. Moving on to the question 2, we are looking specifically at the bleaching stage. The main goal here is to remove the last bits of lignin, which are the chromophores that give pulp its brown color. As shown on the slide, this process relies on oxidation. When we add agents like chlorine dioxide or hydrogen peroxide, they attack and break the lignin into smaller fragments. These fragments then become soluble in water, allowing us to wash them away and leave behind pure white cellulose. When we compare agents, chlorine dioxide is highly effective at targeted lignin removal. However, hydrogen peroxide is often called a green chemical because it is environmentally excellent, breaking down safely into just water and oxygen. Finally, answering the ethical issues, our primary professional duty is safety. Historically, using pure chlorine gas created dioxin that poisoned water supplies. Today, we have an ethical responsibility to use safer chemicals and maintain strict protocols to protect both our workers and the local ecosystem from hazardous leaks. Finally, In question 3, we address the physical processing and the importance of sustainable forestry. The journey starts with chipping, where logs are cut into uniform pieces to allow for better chemical penetration. After the pulping and the screening stages are complete, the pulp undergoes drying. This is critical step because it removes water to make the product lightweight and efficient for global transport. As I mentioned earlier, the chemical recovery system is what makes this entire industry possible. Looking at the loop on slide, the mill functions like a mini power plant. We evaporate the black liquor, burn in the recovery boiler to generate energy, and use the smelt to regenerate fresh white liquor. To bring us to our professional responsibility in forestry, it isn't enough to just run an efficient mill. We must ensure a cycle of growth through reforestation. By only sourcing wood from FSC certified forests and actively protecting local biodiversity, we ensure that our industry supports the ecosystem rather than destroying it. That concludes the pulp and paper part of our presentation. Now let's shift our focus to the chemistry of dyes, pigments, and paints.
Hi everyone, today I will explain the cocoa processing steps starting from cocoa beans until cocoa liquor and also discuss ethical issues in the cocoa industry. Okay, let's take a look at the first question, which is explain each stage of this process. First step is fermentation. Fresh cocoa beans are placed in boxes or banana leaves for about 5 to 7 days. Microorganisms like yeast and bacteria break down the pulp surrounding to the beans. This process generates heat and develop important flavor precursor that will later form chocolate taste. Next is drying. The fermented beans are dried under the sun or using dryer to reduce moisture content from about 60% to around 6 or 7%. This prevents mold growth and prepares the bean for storage and transport. After drying, the beans are roasted at temperature at around 130 to 150 degrees Celsius. Roasting enhances the chocolate aroma, reduces bitterness, and kills remaining microorganisms. It also makes it easier to remove the shell. Then the roasted beans are cracked and winnowed to remove the shell, leaving cocoa nibs. These nibs are ground into a thick paste due to the release of cocoa butter. The final step or the final product is cocoa liquor, which is smooth liquid paste of cocoa solid and cocoa butter. This is the best ingredient for making chocolate and other cocoa products. Next is process flow diagram. As you can see in this slide, this is the complete cocoa processing flow diagram for from beans to cocoa liquor. And lastly, ethical issues. Despite its importance, the cocoa industry faces serious ethical issues, especially in major producing countries like Ivory Coast and Ghana. One major issue is child labor, where children are involved in hazardous work such as carrying heavy loads or using sharp tools. Another issue is low wages for farmers. Many cocoa farmers earn below the poverty line, making it difficult to sustain a decent living. They are also concerned about a forced labor and lack of access to education. Okay, so let's move on to the question number 2. Okay, so for the question number 2, I will talk about the cocoa butter production. Okay, the first one is separation process. Cocoa liquor, which is a mixture of cocoa solid and cocoa butter, is subjected to hydraulic pressing. During pressing, high pressure is applied to separate the fat from the solid component. The liquid fat extracted is a cocoa butter, while the remaining solid materials forms a cocoa cake. The cocoa cake can later be processed into a cocoa powder. This separation is mainly a physical process based on differences in fat content and density. Okay, so for the next question is triglyceride structure of cocoa butter. Cocoa butter is mainly composed of triglyceride, which is a molecule made of one glycerol backbone attached to 3 fatty acids. These common fatty acids are palmitic acid, stearic acid, and oleic acid. As you can see in the slide, I already put it in the slide. This triglyceride gives cocoa butter its unique melting behavior, which is solid at room temperature but melts near body temperature. Now, let's take a look at the last question, which is product quality. The cocoa industry has a responsibility to maintain high product quality to ensure safety and consistency. First, a proper processing condition must be controlled, such as a temperature during roasting and pressing. Second, contamination must be avoided through a good hygiene and storage practices. Third, companies must follow the international standard by organization like International Cocoa Organization. For the question number 3, I will talk about the Maillard reaction, which is a very important reaction in this process. The Maillard reaction is a chemical reaction between amino acid and reducing sugar that occurs during heating. It is responsible for the development of brown color aroma and complex flavor in foods such as roasted cocoa, bread, and coffee. In cocoa processing, this reaction mainly happens during roasting, where flavor precursor formed during fermentation react to produce chocolate aroma compounds. This reaction enhances taste by creating nutty, caramel-like, and roasted flavor. The simplified mechanism for this reaction, as you can see in the slide, the reaction begins when the amino group of an amino acid reacts with the carbonyl group of a reducing sugar. This forms an unstable intermediate called a Schiff base, which then rearranges into more stable compound. Through a series of reaction, these compounds eventually form a complex flavor molecules and brown pigments known as melanoidins. Lastly is ethical consideration or food additives. Food additives are often used to enhance flavor, color, and shelf life, but they raise ethical concern. First, there is concern about consumer health, as excessive or unsafe additive may have negative effect. Second, transparency is important. Consumers have the right to know what is in their food through a proper labeling. Third, companies must avoid misleading marketing, such as claiming products are natural when additives are used.
Hi, now we moving to the pharmaceutical industry. So basically, the process start with raw materials followed by chemical reaction to produce the drug. As you can see, the product is then purified, formulated into tablets or capsules, and finally packaged. As you can see here, the process goes from raw materials to the reaction, purification, drying, formulation, quality controls, and packaging. Each stage is important to ensure the drug is safe and effective. Now for the clinical trial ethics. So basically, participants must give informed consent and understand the risks involved. As you can see, the researchers must protect participants and ensure transparency. The patient safety should always come first. For the aspirin synthesis, so basically aspirin is produced by reacting salicylic acid with acetic anhydride. As you can see, this form aspirin and acetic acid as a byproduct. For the aspirin structure, looking at the structure, so basically the aspirin contains a benzene ring with a carboxylic acid group and an ester group. As you can see, these functional groups are responsible for its properties. For the quality control, so basically it ensures the drug is safe, effective, and consistent. This involves testing raw materials, monitoring production, and checking the final product. For the next slide is for GMP or good manufacturing practice. So basically it ensures products are produced consistently according to quality standards. It helps prevent contamination and errors. For the quality control system, so basically testing is done at different stages, including raw materials, during production, and final products. As you can see, only products that pass all tests are approved. So the final the finally is for the professionally responsibility. So basically, pharmaceutical professionals must ensure drug safety and follow regulations. As you can see, they must act quickly if any issue occurs and always prioritize patient safety. Thank you.
Now, focusing on question 1 of dyes, pigments and paints, we start with the synthesis of azo dyes, which are the most common synthetic dyes used in the industry today. As shown in our synthesis steps, this involves two specific stages. Diazotization, this is the cold step where we react an aromatic amine with acid at temperature below 5 degrees Celsius to create a diazonium salt. Azocoupling, we then mix this salt with another aromatic compound to form the stable N double bond N bond, which is the chromophore responsible for the bright color. However, we must address the environmental pollution issues associated with these dyes. Because they are designed to be permanent, they are difficult to remove from wastewater. In river, they block sunlight, which stops photosynthesis and kill underwater plants. Furthermore, some dyes can break down into cancer-causing amines, making it our professional responsibility to ensure strict wastewater treatment. Moving on to the question 2, we will look at the detailed chemistry involved in paint production. A high-performance paint is defined by three functional components: the pigment, which provide color and the hiding power needed to cover a surface. Next, the binder, often called the film former, which acts as the glue to hold the pigment together, and the solvent, which adjusts the viscosity for easy application and must evaporate perfectly to allow for a smooth finish. Looking at our process diagram, the most critical stage is dispersion. In this step, we use high shear mills to break up pigment agglomerates into fine uniform particles, followed by the let-down stage, where we stir in remaining liquids and additive to set the final gloss and thickness. Finally, every batch undergoes strict quality control to ensure the color and consistency are perfect before packaging. Beyond the technical step, we must also address our professional responsibility regarding organic solvents. Traditional solvents release volatile organic compounds, or VOCs, which contribute to smoke and pose serious respiratory risks to workers and painters. As future industrial chemists, our ethical duty is to lead the industry away from this solvent-borne system and toward water-based paint that protect both human health and the environment. Thank you for your time, and that's all for my part. Thank you.
Okay, so the question number 3 in dyes, pigment and paints are drying mechanism. After a coating is applied to a surface, it must dry to form a solid protective layer. There are two main drying mechanisms. First is physical drying, where the solvent or water evaporates into the air, leaving behind a solid film. Second is a chemical drying, where reactions such as oxidation, polymerization occur, forming a strong and durable coating. For example, some coatings react with oxygen into the air to harden, while others occur through a cross-linking between polymer chains. The drying rate depending on the temperature, humidity, and airflow. Next is water-based vs solvent-based paint. Water-based paint use the water as the main solvent, while solvent-based paint use organic chemicals. Water-based paints are more environmentally friendly, have a lower odor, and are safer to use. However, they may take longer to dry and can be less durable in harsh conditions. Solvent-based paint dry faster and provide more durable and glossy finish, but they release harmful volatile organic compound, also known as VOCs. As you can see in the slide, these are the comparison table that I put it. Lastly, health impacts on workers. Workers in the coating industry may be exposed to harmful chemicals, especially from solvent-based paint. Inhalation of VOCs can cause headache, dizziness, and long-term respiratory problem. Skin contact may lead to irritation or allergic reaction. Long-term exposure can also affect the nervous system. To reduce the risk, industries must provide a proper ventilation, protective equipment, and follow safety guidelines from organizations like Occupational Safety and Health Administration or OSHA.
For question 1A, the purity of fine chemicals is very important because these chemicals are used in products like pharmaceuticals, food, and cosmetics. High purity ensures the product is safe, effective, and consistent in quality. If there are impurities, it can reduce the performance of the product and may even cause harmful effects to users. For question 1B, the production of fine chemicals involves several steps. It starts with the raw material, then goes through multi-step reactions to form the desired product. After that, purification is carried out to remove any impurities. This step is very important to make sure the final product has high purity and meets the required standards. Question 1C. There are ethical issues related to cost and quality. Some companies may try to reduce production costs, but this can affect the quality of the product. If the quality is low, it may not be safe for consumers. So industries must balance cost and quality and ensure that safety and product standards are always maintained. Next, for question 2A, esterification is a chemical reaction between a carboxylic acid and an alcohol to produce an ester and water. This reaction is usually catalyzed by an acid such as sulfuric acid. It is a reversible reaction, so the condition must be controlled properly to get a higher yield of ester. For question 2B, the structure of an ester consists of a carbonyl group and an alkoxy group, which is written as RCOOR. Esters are known for having a pleasant smell, which is why they are commonly used in perfumes and food flavoring. They also have lower boiling points compared to carboxylic acid. Question 2C. Process control is very important in esterification. Since the reaction is reversible, removing water can help shift the reaction forward to produce more ester. Other factors like temperature, catalyst, and reaction time must also be controlled. Proper control helps to increase yield, improve product quality, and reduce waste.
Okay, I will talk about the question number 3 in organic chemistry for fine chemicals. Okay, the first one is difference between batch and continuous process. A batch process operates by processing a fixed amount of material at one time. All reactants are loaded into the reactor, the reaction occurs, and then the products are removed before starting the next batch. This method is flexible and suitable for small-scale, high-value product, but it can be time-consuming. In contrast, a continuous process operates without interruption. Reactants are continuously fed into the system and products are continuously removed. This allows for a higher efficiency, consistent product quality, and large-scale production. However, continuous systems are more complex and require careful control. Next is the process flow diagram. Here is the process flow diagram for this industrial system, as you can see in the slide. Next is professional responsibility in process safety. In industrial process, safety is a critical responsibility for engineers and professionals. First, they must identify potential hazards such as high pressure, temperature, or chemical leaks. Second, a proper design and maintenance of equipment must be ensured to prevent accident. Third, safety standards and regulation must be followed, such as those provided by Occupational Safety and Health Administration or OSHA and the Institution of Chemical Engineering. Professionals must also ensure proper training for workers and be prepared with emergency response plans. Failure to follow safety responsibilities can lead to serious accident and environmental damage, such as the Bhopal disaster.